Hi, welcome back. This is going to be the last part of lecture 2 of our data structure course. Now, previously we talked about the idea, the conceptual thing, which was our ADT for rational number. And from there on, we sort of have this class diagram, right? We have a class diagram here where we made things a little bit more formal. We defined the data type for the numerator and denominator. We said that these are the things, these are the attributes for a rational number that we want to store. And on top of that, we defined some operations. And I haven't really written down all the operations here. I have add, where you pass another parameter, another rational number, and the output of this operation is going to be another rational number. So that's that. We got add, we got subtract, multiply, and divide. And along with that, I think we had another operation called reduce. Just to give it another flavor, I suggested that we add another operation or another method. It's going to be called as decimal, which is going to convert the rational number to a regular floating point number. So that's that. And in this part, what I'd like to do is I want to take this concept, which translated into a model, like a class diagram. I want to take it from there and to implement that in C++ to show you what it really is, okay? So here we got this IDE CLine, and we're going to create a new project for a C++ project, and we will give it a name, okay? Now, as we go through this course, I want to make it more and more professional as we go, but to start with, I'm not following all the good practices, just to keep it simple. So I don't have any folder or directory hierarchy established here. I don't even have any Git repository set up, which we will soon do, but not in this lecture, okay? So we are just going to create this project in CLine. It's going to be called rational number because that's what we are building. And what you can see in here, it gives us a boilerplate code. It has hello world written in it. If I expand the project structure itself, you'd see that we got a main CPP, and this is where the main code is written. And perhaps the text is still too slow, not too small rather. Let me see where that setting is. So I went into file settings, and if we go to editor, I think there we have the font. Right now I got it to 22. Let me make it 28. Yeah, that's a little bit better. Okay. So in the main function, we have std : cout hello world, and then we have a std endel. Okay. Cout, well, I will explain these things later. I think, this is not really the thing what we wanted to cover in today's lecture. So for now, let's just assume, or let's just take it for granted that if we want to print something, like if we want to print hello world, we'd have to say std : cout, and then put two arrows like this, and then type in hello world, and then at the end we'll put an endel, which really says that end the line here, okay? And then we say return 0 because we want to give the control back to the operating system, and we say that there were no errors running this program. That's what 0 signifies here. And if you were writing code in C, you already are used to including stdio.h. This is different, where in C++ we could still include stdio.h, but the practice is we are going to use a higher level input-output library, and everything that we're going to use is coming from IO stream. That's the header file we are going to include. rather than doing anything at all, just going with the boilerplate code that we are given, let me just run this. And what you'll see is that it will build the project. We will have an executable, and it also runs this executable. It says hello world. Okay, so that's that. But in our case, we want to work with this particular data type that we are about to create. Okay. Let me make this a little bit bigger because I got room in here. All right. And a little bit more. Oh no. Yeah, right. So I got a bit more room in there. Okay. Now, just to give you an example, what I was saying is that we can declare a variable x equal to 10, and then we have another variable y equal to, say, 20. We could write z equal to x plus y. And in C++, you can just get the result of this variable just like so. So it's going to attach z along with hello world, which is going to look bad, but let's do this anyways. Yeah, we got hello world 30. All right, not too bad. And if you're really picky about this, you could just put a space in here so that we have a little bit of a separation from the rest of it. However, we're not here for integer x, y, and z, right? What we wanted to do is to create something else. We wanted to be able to write rational number x, and in there we want to initialize this with some value for numerator and denominator. So let's say I want to add 1 by 3 to rational number y 2 by 5, and then we can do something like rational number z equal to x dot add y. So this IDE that we are using, this in CLang, it's pretty powerful. I mean, you don't even have to build your project to see the compile errors. You can see the compile errors right away. You can see this rational number thing is not defined yet, and that's why we have this error. We are soon going to fix these things one at a time. Okay, our target is to create this data type so that we can facilitate all these things. And for now, let me also comment this out because it probably doesn't make much sense. So all these things are gone. We are working with a new data type called rational number, which doesn't exist yet. I want to create a variable called x, another variable called y, and we will add y to x, store the result in z, and then somehow display it. For now, we don't even have that feature. We don't get to see the output of z yet. Oh, and by the way, I made a really stupid mistake in the last one. I was playing that video, and then I noticed is that what I wrote is 1 divided by 5 plus 1 divided by 3. I wrote this is equal to 11 by 15. Yeah, that's what I wrote. I don't know how I did it. What I then figured is that the initial example, what I had is that I had 1 by 5 plus 2 by 3, which actually is equal to 11 by 5, but 15, not the other way, not the other one. 1 by 5 plus 1 by 3 is 8 by 15. Yeah. All right. So yeah, that mistake is there in part B of that lecture, of this lecture 2. I'm not going to edit that out. Yeah, sometimes I make silly mistakes and I'll let it be there. Okay. So that's that. Now coming back to this, we don't have this rational number type yet. This is the sketch of it. This is the class diagram of it. In order to create this data type called rational number, what we really need to do is to create a class. And like I said before, that a class is like a blueprint. It's a design, and based on the blueprint, you can create as many rational numbers as you want. Those things are going to be called the objects. Okay? And I was just abusing this term variable to really mean objects. So from here on, I think that's what I'm going to call them. So rational number is the name of the class, and X is an object of that. Okay. And as soon as we created this thing, as soon as we created this class called rational number, you see that the compiler is gone. We have some other errors now, excuse me, which we're going to fix, but yeah, at least the type is known. So the first thing I want to create in here, just like the diagram says, is I want to create this data type, or the attribute rather, for numerator. And also I want to create one for the denominator. Okay, so that's the first thing. That takes care of the first box I got. Actually, the second box. The first box has the name of the data type itself. And then I need to create a function, which in object-oriented programming is actually called a method. And it takes a rational number as parameter. It spits out another rational number. So the return type of a function comes first. So we write rational number. The name of the method is called add. It takes rational number y as parameter. How does it do so? Well, we will soon figure that out. We don't know yet, but we will figure this out. We will have something like a rational number z, and then of course we will return this back. Okay. So yeah, that almost fixes this problem. It still doesn't. It says add is a private member of rational number. And this is something I didn't talk about, and I skipped it intentionally, but I don't really have a choice anymore. So these things need to be accessed from outside. Like when we declare a data type, we are defining some methods, and from within the class, if we call the other methods, they're all accessible because it's all part of the class. But if we want to access something from outside world, like from main, if I want to do something with rational number, these things have to be accessible, and that's what I'm mentioning here with these plus symbols. So if we put a plus in here, that really says that this is going to be public, this is accessible from outside. Now, in order to write that here in C++, we will have to type in public and put a colon right after it. Okay, it says that this is now going to be accessible from outside. And let me delete these comments because they don't really mean much anymore. Now you see that we don't have any error in this line at all. Okay, it's taken care of. We have this z defined, and it's all fine and dandy. So this doesn't work yet. I mean, I haven't implemented anything, so I can't really expect anything out of it. We have another error, and this is not taken care of here in the design. What's missing is that if I want to create this object called x, which is a rational number, or if we want to create another rational number called y, where I'm passing the parameters for numerator and denominator, what I'm really asking for is some constructor which will construct this rational number for us given the numerator and the denominator. These are the things we are passing, right? How do we do it? Okay. The way you define a constructor is you just create a function or create a method with the same name as the name of the class. It's just that simple. So rational number, you put in two things. You put in the numerator, you put in the denominator, and like it goes, you just type in numerator, which is an attribute of the class, is equal to the number you're passing. I don't want to use the same name, although we can, and in the examples that are coming up in the upcoming classes, that's when I'm going to do that, because it makes more sense that way. However, to keep it simple, I'm just going to write denominator equal to den. Okay, so you see this is the parameter that gets passed to this attribute of the class. So essentially what is happening is that if I pass 1 as numerator and 5 as denominator, I'm actually passing this value through the parameter and it gets stored in the attribute. And the same thing goes for the denominator as well. The syntax highlighting of CLion, it's really cool. It tells you the entire story that how you're accessing the values, how you're sending the values like through den, and where it is actually getting stored. You get to see that right in front of you. Okay, all right. So yeah, we got this stub or the placeholder for an add method, and we got the constructor, and now you can see that there are no more errors. It actually can compile, but we don't get to see the output, right? So it would probably be better if we can have a method like print. If I have this object x, y, or z and I call this print method, what I'm expecting is that it's going to print out the rational number. Like it's going to print out the numerator, put a slash, and then put the denominator after that. That's what I'm expecting. All right, it doesn't do so right now, but let's do something about it. That method doesn't need to return anything at this point, so we're just going to call it void as the return type, and the name of the method is print. We don't have to pass any parameter because the attributes are already here. And what we need to do, just like you have seen in the example, we have to say std 2 colons and then cout. We are going to print the numerator. We're going to put a slash, and then we are going to excuse me, we're going to put the denominator and std 2 colons in del, right? So that's the print method. So let's try this out. x.print, y.print, and z.print. And I'm going to run this project again. Now we got an error. How cool is that? All right, so yeah, understandably so, and it did mark this thing already. So we got this rational number z, and the matching constructor expects that we pass 2 values, one for the numerator and one for the denominator. We didn't do any such thing. So let me do something like this, that initially numerator is 0 and denominator is 0, which gives us an undefined thing. Oh, that's all right, right? Yeah. A little bit of undefined is pretty good. So we got 1 by 3, we got 2 by 5, and 0 by 0. This is something that has to change. It has to give us 11 by 15. How that's going to happen, this is what we are going to define. Okay? And going back to the drawing board, right? If you remember how we did this math, and if I can remember, why is it so tiny? Yeah. I need another page. All right, so we had 1 by 5, and the other number that was 2 by 3. So this was x, and this was y. We want to add them together to get z, right? And the way this goes is that you have to multiply the denominator. So this is like 5 times 3. And then you have to see how many times can 5 divide this number. This is 15, so it's actually 3 times. So you got 1 times 3, and add to that how much? You have to see how many times 3 can divide 5 times 3, and that's 5 times. So you got 2 into 5. Okay. So if you consider this to be the numerator, and let me shorten it out, or let me call this n and this d, and here I got n and here we got d. So essentially what we are trying to build, z is equal to x dot denominator times y dot denominator. All right, and then we have x's numerator, right? So we have x's numerator times y's denominator, and on the other side we have x's denominator times y's numerator. So that's the entire math formula that we got, and we have to code that somehow in C++, which is supposed to be quite easy, really. Now, to keep things simple, I mean, we got one part. We got one number as x, which we don't have right now, but we do have that. Okay, this is what we are talking about. When we call add, we have that on one side. So what you have to understand is that we have an object, and on top of that we are calling the add method. So which object are we talking about? We are talking about this object. Okay, so this is in our hand already, and in order to get this is nothing but a pointer to an object, or you can think of it as a variable. Now, in order to get the value from the pointer, we have to dereference that using this asterisk symbol. So here we got x and we got y, but somehow we need to construct the z. How do we do that? Well, we get two parts. One would be the numerator, and the other one would be the denominator. All right. So the denominator part is really very simple. This is going to be x's denominator times y's denominator. How do we get that? We say just like this: x's denominator times y's denominator, and on the top part for the numerator we have x's numerator times y's denominator plus x's denominator, and what else? Multiplied by y's numerator. Okay, so with that out of the way, we got both the numerator and denominator. Now, constructing z out of this is really very simple. For the numerator part, we're going to pass the numerator, and for the denominator part, we're going to pass the denominator. And that should be it. Yeah, we got 11/15. So that does exactly what we were expecting. We got the add method. If we can do the add method, we should be able to do the subtraction as well, because the only thing that changes in subtraction is this part right here. Multiplication and division, they are a little bit different, but not really anything difficult. For the reduction, if you want to reduce a rational number by dividing both the numerator and the denominator by a common divisor, then you can find the GCD and then divide it by both the numerator and denominator. So that's something we can easily code in, and we can also write this as, what was that? What did I call it? As double, I think. No. It was on page 4. Yeah, as decimal rather. So we can write this method as decimal, which is going to give you a floating point representation of that number. And that also is supposed to be really very simple, because you just need to divide the numerator by the denominator, but make sure that you're doing a floating point calculation at that. Okay, so I want to leave all these things as exercises, like the implementation of the other methods as exercises, and I would invite you to write and test them out with some sample data. Okay, so what have we covered so far? We have talked about abstract data types, what they are, and as an example, I picked up rational number. I wrote the abstract data structure, how that defines the rational number, and the operations that can be performed with on rational numbers. So that was the ADT part, and then we went for something a little bit more formal. We made it a class diagram, which is not a program yet, where we specifically wrote down the data type for each of these attributes. We wrote down the signature of the methods. We defined what's the input parameter and what's going to be the output for each of these methods. But it didn't really tell us how to do the math, right? This is what we implemented right in here in our program. So we created our data type, we created our class called rational number, and then we used this in our main method. We created objects of rational number x, y, and then for z we added y to x, and then we got this result. We printed them out. There are a lot of things that I'm doing wrong in a sense that they should really be done in different ways. I should be more professional about it, but this was not the target. Okay, like I said right at the beginning, that I'll probably be breaking quite a few rules here, but with time we can fix them. We can learn more and more about how we should write these classes, how we should organize them, and yeah, how we can test them out, everything up. Yeah, the whole thing. So we'll be changing those things along the way, but for now this is actually not a bad start. Okay, so we have defined this this new data type called rational number. It only has the add method, but you can fill in the rest. And from here on, if we can understand this, we can dive into the real data structures that we are supposed to learn in this course. So that's what we're going to pick up starting from the next lecture. Okay, so till then, bye.